Hey guys, good morning.
Good morning.
Hey,
Good morning, all.
good morning. Just wait for 1 or 2 minutes. Okay. Hey Barkvi, good morning. Okay, yes, let me share my screen. Okay. So, yesterday we discussed about class A, class B, and class C. Okay. So, what are these class A, class B, class C? So, all our public and private IPs are categorized in these three classes. We have class D and class E also there, but that is for different purpose they are using, but we are not using that. Okay. We are using only class A, class B, and class C. Okay. So IPv4, what is how many octets we have? Yesterday what we discussed.
4 octets, huh?
4 octets. Very good. In each octet, how many bits?
8 bits.
8 bit. Very good. So we have 4 octets. So the number starts from 0 to 255, the maximum IPs we can get for each octet. Right? This is the maximum number we are getting it. 255. 0 to 255. So these are the maximum numbers we are get for each octet. Okay. So class A, how we are going to design? Class A start from 0 to 126. Okay. Class B starts from, yesterday we saw that, right? 128 to You can see the list also here. So class B starts from 128 to 191. Okay, 128 to 191. And class C start from 192 to 223. So this is the numbers for class C, class B, class C. These are public IPs. It is including public and private. So where is the private IP, sir? What series we have for private IPs? Okay. So here 0 to 126 means what do you understand? Starts with 1 dot 0 dot 0 dot 0, like up to 1 dot 255, 255, 255 maximum number. So you can then start 2 dot 0 dot 0 dot 0, 2 dot 1 dot 0 dot 0. Some the random numbers like that. The series starts like that. Okay. For example, class A number. I will give an example like that. Okay. Starts from, we are not using 0. We will discuss what is the why it is not using. For example, first number 1 dot, here 0 dot, third octet 0, fourth octet 0. And second number 1 dot 0 dot 0 dot 1. Okay. Third number 1 dot 0 dot 0 dot 2. Fourth number 1 dot 0 dot 0 dot 3. So up to how many numbers you can generate here? Maximum. What is the last number I will get here? What do you see here? 0 to
255, no?
255, right? So that is the maximum number you will get it, 255. So after 255, what happened? After 255, what happened? Then start
Again 0.
1 dot, here 0, right? It will start 1, 0, start 1. Then 1 dot, 1 dot, 0 dot, 1. Sorry, 2. The same way. Then 1 dot, 1 dot, 0 dot, 3. 1 dot, 1 dot, 0 dot, 4. Up to 255. Then what happened? 1 dot, what will be the next number? 2 dot, right? So it's over now. 255 is over. So you cannot generate more than this number with the same series. So then 2 dot 0 dot 1, 1 dot 2 dot 0 dot 2. This is the way it is going to get it. 3 up to 255. Then 1 dot 3 dot. Up to 255 you'll get it like this. 255. Then here also we'll get 255. Here also 250. This is the maximum number we can generate. This is the process. These the numbers are generated like this. Okay. So this is the networks we are going to generate it for the series 1. So then we'll go for 2 dot, then 3 dot, 4 dot. So you can see this series is a changes. Maximum number you'll get it is 255 everywhere. Okay. So the series which is start from 0 to 126, that comes under the class A. So here what they are going to do, only 10 series out of 0 to, between 0 to 126, only 10 series they are allocating for private IPs. This is the private IP series from the class A. Class A. Class B series come from this list. Out of 128 to 191, we have you can see 172.16.0.0 to 172.31.255.55. This is the private IPs comes from this particular series. So 128 to 191, in between that, we are going to assign one particular series for private IPs. Okay. Here you can see one particular series out of this range, we can design for a private IPs. Here also 192, 223, in between this range, we can see 192.168. This series, they're designed for private IPs. So particularly these series are allocated only for private IPs between these ranges in class A, class B, class C. So what is the difference between public IP and private IP?
Private IP means it will access in the internet. Public IP means inside the network.
Okay. So if you have internet, these IPs, public IPs are unique. Why?
They are dynamic IPs
Public IPs are dynamic IPs, correct? But why it is unique?
because it changes every time when you are connecting to the particular
No. What is the meaning
site.
of unique? Unique means if, for example, one device have one public IP, that public IP, for example, I have one device, one server, for example, I have one server. This server have IP address called 55.120.21.41. So, some number. This is a public IP. This IP is assigned to this server. Okay. This IP cannot be repeated in all over the world. So any other device does not have this number because this is the public IP is assigned to this particular device. Why? Because we are connecting through internet, right? For example, if you have two servers have same IP, you are connecting to through the internet, what will happen? Are you able to connect? Which server are you able to connect?
No.
We cannot connect, right?
Yes.
So because internet is it's not a specific boundary, we don't have it. We can connect anywhere in the world through the internet, right? It might be your server in Africa, your server in US, your server in Australia, wherever it is, you are able to connect from your laptop. So that particular device should have a specific dedicated public IP, right? So this public IP once is assigned to one device, you cannot reuse this public IP until unless you can remove this. Okay. This public IP is attached to the one device, it is only for this device. You cannot reassign this public IP to any other device until unless you detect it or you can remove that IP from this particular device. Okay. So because it's a internet is it's a completely global network. You can connect from anywhere to anywhere. So how you are going to identify with each device in the network? With the public IP. Okay. It's a entire globe is a single network. if you are connecting through the public IP. So that's the reason public IPs are not, no two devices does not have a same IP, because IP is a identity of each device, right? In this entire globe. So, but what about the private IPs here? Private IPs are have a boundary. Okay, for example, your office, okay, network. So if you have an office network, if for example I give IP address like this, 10.0.0.0/16. So we will discuss what is the restriction later. Okay. So I have 4 devices here, 4 servers. Okay, this server have the IP address 10 dot like 0.0.1. This is 2, 3, 4. So 10.0.2, 10.0.0.4, like. So these all are inside the network. Okay. So these within the network, you can communicate each other with the private IPs within the network. If you try to connect outside this network, you cannot. Okay. If you try to, someone is trying to access these servers, they cannot access it, because they have a boundary. This particular boundary, only those within this boundary they can able to connect with the private IP. You can create another network also, same network, same series, 10.0.0.0.16. So here also I have 4 devices. So the same, what would be the first number you are getting it? 10.0.0.1. Same way, 10.0.0.2. This is 3. This is 4. So you can see same number, 10.0.0.1 is here, 10.0.0.1 1 here. Both are same IPs. So there is no unique here. The duplicate IPs are here. So still, but still it is working. Why? Because there is no link in between these two. Got it? This because we have set up a boundary here. We are trying to communicate the service within the network with these IPs. This IP can connect this one. This IP, this server can connect this one. This IP can connect this one. But this server cannot connect to this server, or this server cannot connect to this server, because these servers are in this network, these servers are in this network. It is completely isolated. There is no link in between these two. Got it? So that's the reason private IPs can repeat it within the network. We don't have any duplicate IPs, because in this network you cannot generate one more 10.0.0.1. It is not possible. You will never get it, because within the network these IP is unique. But outside this network, another network, you can have a same IP. So the private IPs are working within the network, within the network boundary. But public IPs are working in globally. That's the reason public IPs are unique all over the world. Okay. So public IPs, if it's unique, right? We told, right? So that's the reason you have so many lakhs of crores of servers are available in the internet. Every device, for example, your mobile is trying to connect, or you have multiple servers. We are trying to connect to the internet. We have VPN gateways, firewalls. We have many devices that require public IP to connect to the internet. So in older days, the public IPs are, IPs are enough to manage your devices. But nowadays, so many servers are coming to the public. They are going to use the public IPs. So we have some limitation. So that's the reason public IPs are costly, and it is not like, we have to reserve that IPs, by like, your service provider. Like, for example, Airtel or Jio, who are internet service provider, they they need to buy the public IPs and reserve with them, because they are doing a business, right? So they are reserved for that public IPs. They will buy some public IPs from the authority, IANA authority. So they are reserved for that. Okay, these many public IPs, I am going to use it. These many public IPs, this another company is using it. Okay, public IPs are expensive, and they have to reserve some IPs with them. Otherwise, we cannot allocate. But private IPs are not like that, because we are working within the network. We cannot go beyond that. Okay. So that is the difference between the public IP and a private IP. You can see here, public IPs are registered on internet. Public IP address is unique, no duplicate anywhere in the world. Assigned to your network router by your internet service provider. You can see here, this example, I have a network, internet available in my house. So here what I'm supposed to do, if I try to connect to the internet, okay, for example, I have laptop, I have mobile, I have desktop, I have some two laptops, one mobile is there. If I try to connect to the internet, okay, so how many IPs are required here? Public IPs. Without public IP, I cannot connect internet. Everyone know that, right? So if I try to connect to the internet now through my mobile or my laptop, my desktop, how many IPs are required here? Public IPs?
Or
Four devices. So four devices, each device have a required of one public IP, right? Otherwise, you cannot connect the internet. So it is very, very expensive. If you use the public IP for each and every device, it is very expensive. So that's the reason what these service providers are doing it. They are using router. Okay. So what this router will do? Router is a interface between your devices and the internet. So any request that should go through the router only. For example, you're trying to connect internet through your mobile. Okay. So, for example, when you try to connect this internet, this particular router, right? This router will generate one IP for this particular device. But these IPs are private IPs. Okay. So what this router will do, I cannot connect internet with a private IP. So my request will go to router first. The router will convert that private IP and try to connect the internet with the public IP of the router. So you cannot directly connect from your mobile to internet. You cannot connect. Your request has to go to this router only, because the router has a public IP, it can connect to the internet. So this mobile is connected to this particular router. Okay. So router is a interface. So one public IP is enough to connect multiple devices. So in this particular router, we have two services are running here. So that is one is the DHCP service. Another one is the NAT service. These two services are running in router. So what this DHCP service do? This service will assign private IPs to the device whichever newly connected to your router. For example, first I connect my mobile to the router. My mobile got one IP address. Who assigned this IP address? This router with the help of DHCP service. So I connected my laptop to the router. So this router will assign one more IP, some IP, private IP assigned here. This service will help to assign the IPs to the devices which are connected to this router. Okay. So once these IPs are connected, then I want to connect to the internet now. So how can I connect that? So the request will come to the router. Router will convert your IP. So this router have a public IP, some 12.15.21.33. Okay. So this router will convert your request as a public IP and connect the internet and get a response from the internet through the router to reach to your mobile. The same way for your laptops, same way for your desktops. This IP actually, if someone is trying to type the IP address of your mobile, he will get this IP. He don't know this IP because to the world, outside your world, they don't know what is IP your mobile have it because you are not directly connected to the internet. They don't know what is the IP address of this, but because we are trying to connect through the router only. So I can see only router IP. I cannot see your actual IP of your mobile. I can see only router IP because I'm trying to through the internet only. I'm trying to access it. If I want to know that what is the IP address of your mobile, I don't know. I know only your router IP address. That's all. Because every transaction, every request has to go through the router only. Without router, if any power down, your router is down, you cannot connect internet. Why? Because router is interface. Router was an interface to between your internet and your device. Without router, you cannot connect. Is it clear, guys?
Yes, sir.
Everyone? Ajay, Bhargavi, Anil,
Yeah, it is. Yes, sir.
and yesterday you want to repeat? Hmm? Anyone want to repeat this one? Is it clear? Because this is the very important concept to understand, like how this private and public are communicate to connect to the internet. Because you can remember blindly private IP, no internet. So, for example, you are in a network, in office network. Okay, you connected over your laptop in office network. So you will get some private IP of your laptop. But you can connect your internet. So how it is possible? you can directly connect with a private IP to the internet? Is it possible or not?
No.
No. So how I am able to connect to the internet?
With the help of router.
So somewhere is there, some device, other interface will be there. Maybe router. Cisco routers. You may heard about the Cisco routers are there. Every network they have Cisco routers or different type of routers are there available in the market, right? So this router have a public IP. So your request will go to the router. The router will connect to the same way. Same thing happened. The response also come from the internet through the router only. So router is playing a key role here. So some device should be there to connect. If you are connecting your laptop or device which have private IP, so it cannot directly connect to the internet. It has to connect to the router only. Okay, router is nothing but our, even though this is in our at house also we have a router. The service. So these routers, these public IPs are provided by this service provider. So in our even in our house also we have internet connection. We need to contact Airtel, or you need to contact the Geo or Act. So many internet service providers are there. Why we need to contact them? Why can't we can directly connect to the internet? Because we need a public IP, which we don't know, which we don't have it, because these particular vendors, they are going to buy these public IPs from the INN. That means I think this is the authority team who are maintain these public IPs. They will contact these guys and buy these public IPs from them. Okay. So whenever they provide internet connection, they will one IP they will assign to you. Okay. This is the process it is working on it. So private IPs, you can see private IPs address are not publicly registered in the internet. You cannot access internet using a private IP address. Use internally inside home business. You can use a private IP. Non-unique can be used on any other private IPs. So each network we can have a same IPs. It is possible. So you can see DHCP service is a service used to routes to assign the private IPs. So it will assign the private IPs to the particular router. NAT is a network address translator, is what to translate a set of IP addresses to another set of IP addresses. So when the request comes to the router, a router will translate it and connect to the internet with the public his public IP. And once you get a request, then it will convert to private IP and send it back to your device. Okay. So this is the process which we are going to connect to the internet. Okay. You can see this is the range of public private IPs. You can see 10.0.0.2, 10.255.255.255. This is the range of class A. This is the range of class B, like 120, 172.16.31.255. The same way 192, 168. This is the private IP. You can see what is the public IP, private IP I have. Let me type my IP config. You can see here. What is my IP here? 192.168.1.6. Is it private IP or public IP? What is our range here? You can see
Private.
192, 168. Which series is a public series or private series? Private IP, right?
Private IP.
Start with 192.168. 192.168. This is the private IP. Okay. You can see we have option called our where is that? My DHCP is, you can see the DHCP is enabled. So if any connection is connected to my device, it will be generate a new IP for that. Okay. Description, physical address is this one. Somewhere we can see the router IP address also. Okay. You can see if I go to 1 minute, guys. If I type here in Google, how do you get a public IP of your device? What is my IP?
What is my IP?
Right? So what it will show? What is my IP? Okay, this is the see. This is my IP address. 122.174.174.199. So this is it. Here it's showing us. If I type what is my IP, it's not showing this IP 192.168. This number, right? This is the private IP in my laptop. But if someone is trying to connect to my laptop, how they are going to connect? They are going to connect with this IP because outside the world they don't know what is the IP of my laptop. It's a private IP. So this IP, which IP of this one?
Public IP.
Public IP for what? Which device is
Router.
public? Router. My router IP address. This is my router IP address. This actually it is not my laptop IP address because outside the world they don't know what is the IP address of my laptop because they're in the different network. I'm in the different network. They don't know. Every communication through happened through the router only, right? So if I type what is my IP, this is my public IP. This is not my laptop public IP. It is a public IP of my router. Okay. Okay. So this is the ranges we have it. Okay. Then this is a private IP, public IP ranges we are going to design. Then we will move to the subnet mask. What is subnet mask? Many places you can see here where we can see 10.0.0.0/16. What is this /16? This /16 we can call it as subnet mask. What is the importance of this one? I want to restrict your IPs. For example, you can see without subnet mask. Okay, how many IPs you may get is 10 dot, maximum is 255 dot, here also 1 to 255, here also 255. These many numbers will get it. So what is the maximum number we will get? How many IPs you can generate in this network? For example, type calculator, open the calculator. You can type 255 into 255 into 255. You can see in one network, if you assign 10 dot 0 dot 0 dot 0, okay, without, for example, without subnet mask, how many IPs you can get in this network is almost 16 lakhs 581 375 devices. So you can assign almost 16 lakhs. It's a very huge number. So no network does have a 16 lakhs of servers in the network. It is not required. So I want to restrict some limit into this network. Okay, maximum these many IPs. I can assign this for this network. How can I control that? With the help of subnet mask. For example, you can take the same example, 10 dot 0 dot 0 dot 0 slash 16. When I mentioned slash 16, what does it mean that? I told you, right, we have 4 octets. This octet 1, octet 2, octet 3, octet 4. So this is octet. Octet means 8, right? 8. So this is one more 8. This is 8, 8. So total 32, right? So when I give as 16, it means I want to say these particular 2 octets are fixed. I don't want to change it. Only these rest of these things, 32 minus 16, you can say. So you're getting 16. That means 8 and 8. These two can change. That means the maximum, these numbers 10.0, this will not change. Always it is there only. So this from octet 3, this can be generate IPs 255 0 255. This is also changed to 0 dot 255 255. So here only 255 into 255 are, sorry, 255 into 255. Maximum IPs you can generate in this network is 65,536. Okay. So here in the same example, I'm going like this, 10 dot 0 dot 0 dot 0 slash 24. This number maximum we can give 32. That's it. The maximum is that one. So if I give that 24, what does it mean that 24?
3 octets will be fixed.
So I'm mentioning here 3 octets. This is 8. This is one more 8, another 8, and one more 8, right? So 8 plus 8, 16, 16 plus 8, 24. These 3 are fixed. No change. So how many IPs I can get here? Maximum only this can be changed. So maximum height IPs are getting it
255.
0 to 255. So in this network, maximum I get only 255 IPs. 255 devices I can add it here. I cannot go beyond that. This is the maximum IPs I can give it. So this is the way we can restrict our IP generation within the network. This subnet mask will help on that. For example, if I give like this 10 dot 0 dot 0 dot 0 slash 25. Now you can say how many IPs you can get. Any guess? We know that, right? 24 means we can fix this one, this one, this one. So here when mentioned 25, that means in here also we need to restrict to 1. So only here we can generate only 7. So you can go back to your chart. Yesterday we saw that, right? You can see 1 octet means 8 bits, right? We are trying to reserve one more bit in the last octet. So that means we are restricting this one also. Okay. We are not using this one. So maximum you will get this one. So how many IPs you can generate here? Maximum of, you can see, open the calculator, 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. Maximum 127 IPs you can assign it because we have reserved this one also. You cannot get this IP at all. Okay. In this network, you will get a maximum of, if I give 26, what happened here? We have reserved this one also. Only these many IPs only get it. So you can add it. Only 64, something like that. You'll get it. Okay. So based on your IP, the subnet mask, this is called, this number is a reserved. So you want to make it as reserved your entire network. So you cannot change it. So for example, if you give, we can use 27, you can use 28. That means these many IPs, octets you are going to reserve. These many IPs are, we are not using these octets at all. Only rest of the things IPs we are getting it. So slash 24 means you are reserved these 3. This will not touch. Only this number will change. These all are fixed. Whatever you see here, the same thing. You cannot change it. Only this will change it to maximum of 0 to 255. So after 255, what will happen? In generally, you can start like this 10 dot 0 dot 1 dot to 1. It will start like that. But if you reserve 24, this cannot change, right? So you will not get any other number here. It is always 0 only. Okay. So that is the power of subnet mask. You can see here in the documentation also. Subnet mask is a, you can see 8-bit is a, we can call as network address, host address. So when you reserve these IPs, right, this part we can call as a network address. This part we can call as host address. So host address can change. Network address we cannot change with the help of subnet mask. Okay. So you can see here this example in the documentation. The subnet must specify which part of IP address corresponding to the network and which part corresponding to the host by masking the network portion of the IP address. You can see here, this is the network, these three are host. So what would be the IP address they given? 1 network, 3 host. What is the IP? How the subnet mask is provided?
8.
It's 8. Because they're going to result only this one. This one we can call as network address. These three are host. If I give 8 here. Okay. If I give 16 here, 16 means these two are network address. These two are host. Okay. If I give 10.0.0.0 slash 24, that means 888, 3 are reserved. So this is network. This is host. Like that. You can see the same example here. This is /8, this is /16, this is /24. Okay. So the bits are, we are going to masking. We cannot use that particular octet. So what we are exactly are mentioning here. I don't want to use this octet anymore. I don't want to change these octets. Only this octet I want to change it. If it is a 24. If it's a 16, I don't want to change these octets. I want to generate IPs here only. The same way here. These three, I want to change it. This is fixed. Okay. This is the way we are going to use a subnet mask and all. Okay. I'm going to stop here, guys, today. We are going to discuss the actual networking tomorrow practically. So how these networks are created, how these devices are added to the network and all these things. Tomorrow, we are going to start with the actual networking. These are the basics actually. What is subnet mask? What is the classes? What is a private IP? What is a public IP? So I'm going to upload these recordings today. Just go through once again because it is not that much easy to understand in a first class. Okay. Slowly you will grab the things. It is not that much easy to understand what I'm trying to say. So go through the recordings once again and try to understand. If you don't understand, let me know. If you want, you have any language barrier to understand, I can explain Telugu also. Don't worry. So we will give some brief. If you want in Telugu, I can give it then tomorrow. So if you want, that is your choice. Okay, guys. I will upload the recordings,
Okay.
guys. Go through that. Okay. Okay. Bye for today.
Thank you. Thank you.
Thank you.
Yeah, thank you.